Hoffman apparatus. Not a Kaufman apparatus. It'd be much cooler. A Hoffman, okay? The name of it doesn't matter. What it does matters. What are these things? Electrodes, wires. They are connected through here. Wires go up into the solution. Okay, and back here, there's, I don't know if you've seen it before, but there's this green box back here. You can plug the electrodes in, flip the switch, electricity flows through. In here, what's in here? What did it tell you? Water. Okay, so does water conduct electricity?
Yes.
Yes, that's why you don't dry your hair in the bathtub. So when I flip the switch on, the electricity is going to decompose. The name of the decomposition is electrolysis. Why do you think they call it specifically electrolysis? Because it involves electricity. Okay, so when I turn it on, what do you see? Those of you that are in front. Bubbles. So you see the bubbles happening? That's the decomposing. So what are your products? What state are they going to be in? Gas. Okay. So let's write down our reactant. What's our reactant again? Water. So write down H2O for your data. And write down its state. What state should we have for H2O?
Liquid.
Okay, so your one reactant. And you could do this, and you might want to do this for your other ones as you're going through. You could write a little note to yourself that it's decomposition, because it's something you're going to have to do in your analysis. Okay.
So what, you write D down?
Yep, so I just make a little note. Alright, so now let's record what's happening in the Hoffman apparatus. What do you see happening? Bubbles. If you can't see them, come on up and check it out.
You get electrocuted if you touch it.
Yes, don't touch the bowls, the metals. Alright, so record that. Record your observation. Record that you see bubbles, so you're getting a gas for products.
We do this under data, or?
Yep, right. Keep doing it in data.
Should we write it like underneath that H2O?
Yeah, I would just write it underneath there. You're just writing notes for yourself. Is it hot?
Yeah.
There are bubbles.
Okay, so John just made a good observation. He said the liquid level is lowering. Do you guys see that?
Yeah.
No. It might be too far. This one is at right here. They both started up way up here. So this one's here. This one's here. Okay. What two gases do you think are being made? Hydrogen and oxygen. Because of their charges, and electricity has charges, right? They get separated. One goes in one column, one goes in the other. Which one do you think there is more of? Would be in this one. Why hydrogen? Because there's two hydrogens for every one oxygen. So we're predicting that this gas right here that stops, it's being collected, it can't escape, that this gas is hydrogen and this gas is oxygen. So what we're going to do is we're going to test to see if that's true. That's what it says on there. We're going to test it using a burning and glowing splint. We tested for hydrogen the other day. Do you remember that?
Yes.
What do we do? The popping thing, right? What do we put in the test tube? The burning splint, and it popped. Did it keep lit or did it go out?
It went out.
It went out. So that's what we're going to do to test for hydrogen. For oxygen, we're going to use the glowing splint, because what do we know about oxygen and fire?
It'll light it up.
It'll light it up. Okay, so, yes, so I would observe maybe that there's more hydrogen than oxygen. I'll write that down. Alright, so I'm going to collect it in test tubes. We're going to do the test, and someone's going to have to come hold them and help me out again. So, the way I collect them, if I open the top up, gas is less dense. It's going to escape up. It's going to push any gas that's in here out. Okay, so this we're predicting is hydrogen. Or no, oxygen, sorry, and this is our hydrogen.
Oh, that's cool sound.
Okay, so we just have tubes of gas. And let's do hydrogen first, since we've already seen it, so we predict what it's going to be. Who wants to give me my cover? Who did it last time? Nick did it last time. Let Mark do it this time. Since he didn't get to hold the camera.
Oh, shit.
Hydrogen
What
first?
camera?
Hydrogen first. Just tighten them up. Okay, hold it out here so everyone can see.
I would say
Okay.
green is my color.
Yeah, humor.
Well, that didn't work.
Damn.
Take 37.
Try that again.
I'm not gonna say anything.
Mark, maybe you'll hear it this
Thanks,
time.
Brady.
Yeah,
Okay.
I missed it last time, so.
Ready?
Someone.
Advantage point.
Uh-oh. Oh no. Whoa!
Okay, so was that hydrogen?
Yeah.
Bet it was. Write down what happened.
It went.
You tested it and it went out. Flaming splint for hydrogen proves you have hydrogen gas.
Nice and
Joey, how do you spell?
Wait, what?
What was in there? What did that just prove?
Bloop. Okay.
Hydrogen gas. What
You
happened?
said
You write down what
something
happened.
serious.
Guys, you are going to have to do these tests on parts of your own lab, so be prepared for that. Okay, oxygen.
wet.
Okay, oxygen, we're going to use a glowing splint, so I'm going to let it burn a little bit, blow it out, we're going to put it in there, and what do we predict will happen? Start on fire. It sometimes does, sometimes doesn't. It might just glow brighter, so you might have to watch carefully, so let's make sure the label isn't there. Okay.
It smells like fire.
That's
Weird.
because there's. Never mind.
Whoa.
Don't drop it.
Oh, it didn't quite relight, but everyone saw it glow brighter?
Yeah.
Okay, so write that down. Glowing splint,
I did feel it.
glowed brighter, it almost relit, so that proves we have oxygen gas. Thank you very much, Mark.
You got it.
I appreciate your help.
It does.
So modest.
That's right, I am, Dan.
Okay. Moving on to the second one.
Seriously. Put into the tube.
Okay.
It proves that it has hydrogen or something.
Alright, so the second one, we're dealing with zinc and sulfur powder.
So now should we draw the line?
Yep, so now I would draw a line. Make sure you guys have enough room to write your procedure in there. If you think you might need an extra line or two,
Yeah.
leave some space and then draw your line. And then write number 2.
It's a good line though.
Okay, zinc, sulfur powder, what states do you think they're in? Solid.
Hey Jesse, do you need me to write your
So
thing?
you have
Could you? Yes.
zinc solid plus
I'm gonna do it messy.
sulfur solid. Are either of them diatomic? No. What kind of reaction do you think this will be based on your reactants?
Is it gonna be over there?
Synthesis.
It's gonna be a big bang in your
Sulfur is this yellow powder, so I'd write down sulfur is yellow. And I'm just gonna put a little pile on this plate. And zinc is this really, really dark gray. Okay, so write that down for zinc. Really, really. Okay, didn't I?
Yeah.
So I'm just gonna mix them up a little bit on here.
It's starting to be
Okay. So, little pile on the plate. What I have here is magnesium. This is just the wick. This is not the reaction. This is just so I can light this without being right next to it while it happens. Okay, which means I'm going to ask you three to stand up and move.
Is it like that hardcore?
It's not that hard, but trust me, you're not going to want to be next to it. You can just go back there.
Should I?
Alright.
I'm not going that close. I'm going
So,
like here.
shh, guys. Alright, so we have magnesium. All I'm going to do is light the magnesium. It'll burn down just like a candle wick, and then it will ignite the zinc and sulfur to make the reaction happen. The magnesium burns really bright. You can look at it. Don't do one of these where you're just... Okay? Because you will see spots. I don't know for how long. Maybe forever.
Let's turn off the light.
Man, it's not worth it.
Oh no.
Okay? Where
actually like taste it.
Okay, so write down observations. What happened? Say it. I said write it. Don't say it. Go back. Or you can stay back there if you want. It's up to you. Sulfur and zinc. Okay, look at what it looks like now. You should have observations of this. It's kind of white with yellow, orange stuff in it. Looks different. What state would you say this is? Solid, so write that down. Because you're going to need that for your reaction. Yellow and orange in it. Yep. I'll leave it here, you can come look at it closely.
Do they use zinc and fireworks to make like a yellowish color?
They might.
They use that other thing.
Okay. Here's what you need to do for tomorrow.
Can I stop it or should I?
Stop.